Here's a torque problem here that involves a big wheel or a big merry-go-round. So imagine this is a merry-go-round in a playground. You're looking down on it. What happens is there's some kids out there on the merry-go-round, and they're sort of pulling on it. Maybe they have ropes tied on it, or they're just pulling on it. This kid is pulling this way at 30 newtons. This kid is pulling this way at 30 newtons. This kid's pulling this way at 20 newtons, and this kid's pulling out this way at 20 newtons. So what the problem wants to know here is what is the net torque on the wheel, putting that torque on it there. So what you have to do then is sort of use your working equation for torque here, that torque is R times F times the sine of the angle between R and F. Moment arm times force times the sine of the angle between the moment arm and the force. To sort of figure then, all right, let's apply this to each one of the forces. Let's figure out the moment arm, the force, and the angle between the moment arm and the force for each one of these here to see if we can work out what the torque would be. So why don't we just go ahead and do that then and see what we get. So what I'll sort of do is I'll just sort of write the torque next to each one of these forces here and see what we can figure out. Start up here. So let's say the torque here due to this one, let's just call it, I don't know, tau 1, I guess, is going to be something like this. Tau 1 is going to be, well, this force here, the moment arm for this force is the full radius of the circle. So there's a big R right there. So right off, it's going to be R for the radius. Now, whatever the radius of the wheel happens to be, you can fill in for that. Whatever number is in your book or whatever number you need for that, go ahead, that's fine. And the force here obviously is the 30 newtons. And now what we need is the angle between the force and this moment arm. Looks very clear to me that it's 90 degrees, so we'll just go ahead and put a sine 90 in there, which is just going to be 1. But okay, there's the torque due to that 30 newtons force. You just need to figure out what your radius is in there. Okay, next one. Let's just keep moving around the circle and hit that next force now. Let's do this one right here, the 20 newton force over here. Well, tau due to this one here, I'll call it tau 2. It's definitely acting at distance r from the axis of rotation because it's right on the periphery of the wheel right there, r. The force is definitely 20 newtons. And now I need the sine of something in there. Okay, what's the angle between this moment arm and this force? Well, the moment arm is straight out this way like that. There's the moment arm. Here's the force. Looks like the angle between them is 0 degrees because they're in the same direction. So you have a sine of 0 degrees right here. But of course the sine of 0 is 0, so that makes the entire torque equal to 0. And I hope that makes sense. If you go up to a merry-go-round and grab a bar or tie rope on it and pull directly and radially outwards, you will not cause the merry-go-round to rotate. So that's going to be a 0 torque for that one. Okay? How about this one over here? Same sort of procedure. We'll sort of right over here. We'll call it tau 3 now, I guess. So tau 3 is equal to something like this force here is acting right here on the merry-go-round. So that's a distance of 0.05 meters from the axis of rotation. So something like 0.05. There's the moment arm right there. And of course the force is the 20 newtons in there. So we have that. Now, what's the angle between the moment arm and the torque? Well, looks like it's 90 degrees in there. So there'll be a sine of 90 in here, which we know is just 1. So tau 3 is a pretty easy number to get there. It's just going to be the 0.05 times the 20, so you can definitely get yourself a number for tau 3. Okay? Last force. This 30 newton force up here, we'll just call it tau 4, I guess. That's the next number we're on here, tau 4, the fourth torque on this bar, or on the merry-go-round, pardon me. Let's see what we have. Well, the moment arm here looks like it's acting a 0.05. The distance is 0.05 from the center of the wheel right there. So we definitely have a 0.05 in there. Okay? And the force is, of course, 30 newtons. And what do we have? Lastly, this angle in here, I guess we didn't write anything in there. You can look up in your book or whatever problem you're working to see what it is. We'll just call some angle alpha in there. So we'll definitely have this sine of some angle alpha in there. And alpha could be anything, 30 degrees, 45 degrees, whatever. Something you'll definitely have to take the sine of with your calculator in there to multiply the whole thing out. But in either case, you can get that fourth torque. It's a number that you can easily calculate now. The form is right. So the last thing we have to do in the problem is we need to add the torques together to get the net torque, but we have to be a little bit careful with the signs. So let's make sure we set up a sign convention. I'll say anything that would cause the merry-go-round to rotate clockwise, I'll call positive, and counterclockwise, I will call negative. So let's see what we get. If this torque had its way, it would cause the merry-go-round to rotate this way like that, and that's the positive direction. So we'll always make sure that whatever we get for tau 1, we make sure it's a positive number. This is going to be 0 here. We don't have to worry about it. This one over here, if this force had its way, it would cause the merry-go-round to rotate like that. That's the negative direction. So tau 3 here, whatever you get, definitely needs to be a negative number in there, and make sure it's negative. Okay? And when we go to tau 4 now, if this 30 newton force had its way, it would cause the wheel to rotate counterclockwise as well. That's the negative direction, so we'll put a big minus sign right there. So tau 4 is going to be negative. So keeping those signs in mind, be very careful with the signs now to answer the question about what the net torque is here. It's just going to be the positive tau 1, whatever we get for tau 1. You can just go ahead and put the 0 in here, but tau 2 is 0. Then you have the tau 3 in here. But when you do your actual addition, make sure you have the minus sign in there for tau 3. And lastly, all the way to the top, we do have this tau 4 right here. Add the tau 4 in there, being sure that when you do your calculation, you make sure that minus sign is in there. That would be the net torque on the wheel.